Hello, good evening everyone. So we're back again to continue with our series. So we started differentiation from chain rule. So in our last video we introduced the concepts and we solved some problems on chain rule. And I told you that the method I'll be using is a very fast method, a very fast approach, such that however, no matter how complex the function tends to be, you can solve that without having to apply that formula in a very short time. So in this video we'll be solving these examples, these four problems here. Because looking at them, they look complex, but then when you approach it, you discover they are not as difficult as they look. So I'll be solving them from the very first one. So the first one, you can see that we have a log function. So we have y equals lim into 2 cos 3x plus 1. So if you remember what we did in our last video, I told you when you have the function of function, chain rule, we said you apply chain rule whenever you have the function of function. So if you remember what we did in our last video, we said for chain rule, you differentiate from the inside to the outside, from the inside to the outside. That is to say, from the inner function to the outer function. Remember, you differentiate the inner function, differentiate the outer function, then you rewrite the inner function. So that same exact thing is what we'll be doing here. So from the very first problem, so the first question I have here is y equals lim. So we have to find y prime. So y prime is going to be writing the answer directly, like I told you, the same principle, it works. So from the inner function, I have 2 cos 3x plus 1. You remember that when you differentiate a constant is a number that stands alone, such as 2 or 1 in this case that stands alone. So a constant is a number that stands alone. So that number, when you differentiate it, it gives us 0. So now differentiating the inner function, if I differentiate 1, I will get 0. Now when I differentiate 2 cos 3x, I'll notice that cos 3x is another function of function. So I will differentiate 3x. When I differentiate 3x, I will get 3. When I differentiate the cos, I will get, so 3 times 2 will give us 6. So when I differentiate cos, I will get minus sine. Then we'll rewrite what we have inside, minus sine 3x. So this is what we'll have when we differentiate the inner function. Then differentiate the outer function, lim. So when I differentiate lim, I will get 1 over. So differentiate lim, you get 1 over. So 1 over the inner function. So we have 1 over 2 cos 3x plus 1, which is the inner function. So we can write this as minus 3 sine 3x over cos, okay, this is minus 6, sorry, over 2 cos 3x plus 1. So this is what we have from that first function. So that is that. Now for the next question, we have y equals tan into sine x. Now the inner function there is sine x. We're differentiating, so y prime is going to be, when we differentiate sine x, we get cos x, that is the inner function. Differentiate the outer, tan x, you get sec squared. Then you rewrite the inner function, which is sine x. So that is the solution to that. We can see how fast it is, irrespective of how complex the function is looking. So I'll be differentiating the third question now. So we are looking at the third question. So we have log x squared base 5. Now in differentiation, we can only differentiate log, that is natural logarithm. So whenever we have log to base of a number, we need to change it to natural logarithm, that is lim. So, and the conversion from your logarithm, you notice that when you have log b, where b is a number, to base a where is a number, you want to change it to lim. So it's equal to lim b over lim a. So that is to say So we can change this from log x squared to base 5. I can write this as, so this can be written as y is equal to lim x squared over lim 5. So this question has been rewritten in this form, lim x squared over lim 5. So differentiating this directly, I can still write this as equal to 1 over lim 5 lim x squared. So differentiating this is very simple. Notice that 1 over lim 5 is a constant, so it's a number, same thing as having 2x, where 2, we don't look at it when we differentiate 2x. So in the same vein, we don't look at 1 over lim 5. So we're interested in differentiating lim x squared. So when we differentiate lim x squared, we start from the inner function. So when I differentiate x squared, I would get, so y prime is going to be, when I differentiate x squared, I would get 2x over lim 5. Then when I differentiate the lim, I would get 1 over the inner function x squared. So this is what we have, so of which I can simplify this. So this can be simplified as y prime being equal to 2 over x lim 5. So this is the solution to the third problem. So this is very direct. So we'll be looking at the fourth problem. So we'll be looking at the number 4 problem. Now this can be simplified as, whenever you have problems to differentiate, it's always best to rewrite them in exponent form. So I'll be doing that here, and we can write this as the same thing as 3x plus 2 raised to the power of minus negative half. So these two things are the same from indices. So I'll be differentiating. So y prime, the first derivative, is going to be differentiate from the inside. So when I differentiate the inner function, which is 2x plus 2, 3x plus 2, then I differentiate that, I would get 3. So differentiate the outer function, which is negative half. So you'll be multiplying by that half when you're differentiating the outer function. You differentiate that, then you rewrite the inner function, 3x plus 2 raised to the power of minus half minus 1. So that is what we have. Now simplifying this, we have negative 3 over 2 into 3x plus 2 to the power of negative 3 over 2. And this can still be simplified as negative 3 over 2 times 1 over the square root of 3x plus 2 all cube. So this could be our final answer, and I think I would leave it like this. So please, if you like this video, if you enjoyed it, please try to subscribe to our channel. Thanks for watching this. We'll be bringing you more problems on this, and our next video will be explaining the concepts of product rule and then the quotient rule. Then after the product rule, we go to the quotient rule, then the implicit differentiation and parametric differentiation, then we'll go to application of differentiation. So make sure you like and subscribe the video. You'll get more videos that would help you. Thanks for watching this.